Right, so I guess we can start.
Yes, we can begin.
Okay, so welcome to the, let me share my screen. Okay. So welcome everyone to the webinar series of the Atmosphere project. Today we're going to talk about how we can combine clouds with Fogbow. Fogbow is a middleware that has been developed in the context of this project. So it's one of the assets that's going to be output of the project. Today we'll have myself and Leandro Ciuffo from RNP, the Brazilian NREN. I'm a professor at the Federal University of Campina Grande in Brazil, and I serve as the Brazilian coordinator of the Atmosphere project. This is a project that's co-funded by the European Commission and the Brazilian Ministry of Science and Technology. It has a European side and the one at the Brazilian side. I am the coordinator at the Brazilian side. Leandro Ciuffo is Associate Director of Advanced Internet at RNP, the Brazilian NREN. We'll be talking about Fogbow and how RNP is planning to use Fogbow in on its cloud strategy. So without much further ado, I will start my presentation talking a little bit about Fogbow. So Fogbow is a microservice-based middleware, which allows multiple ways to combine clouds, including cloud brokering, hybrid clouds, and federated clouds. It's an open source middleware, so we're trying to build an open source community around this middleware. So to do that, we extended the middleware functionalities to way over the requirements for the project, and I'm going to talk a little bit about it in this presentation. The middleware, one of the main features of the middleware is it's completely customizable via plugins. So it can be used in different settings with different scenarios because it's very easy to extend it developing new plugins, as I will show shortly. So before talking about the features that the middleware provides, let us give a brief context of how cloud providers are set. So we have basically two main deployment models for clouds. The original public model, which this was the model that was originally set forward by industry some years ago with Amazon, followed by Google, Microsoft, IBM, and many other companies. In this provision model, the companies have shared multi-site infrastructures, and they leverage on the economy of scale to provide efficient and low-cost access to computing resources. Virtual machines, storage resources, networking resources, etc. Because of this huge infrastructure, the public clouds provide high elasticity, so clients can increase or shrink their infrastructures at will, paying just for the resources they actually using. The cons of the public model is that they might raise some security and privacy concerns, since you are deploying your applications on someone else's infrastructure. So shortly after the boom of the public clouds, some middlewares have been developed to allow institutions to implement cloud services at their own facilities. So this is called the private cloud providers. So they have dedicated, typically single-site infrastructures where they offer the same kind of services that are provided by cloud providers. However, since these private providers are typically smaller than their infrastructure are smaller than those provided by public providers, they are not as efficient as public providers. On the other hand, they bring no new security and privacy concerns. So the privacy and security concerns are those that the company already had to deal with. And because they are less elastic, they normally impose more restrictive usage quotas for users. So users, the amount of resources that the users can get at the same time are typically smaller than what they can get in a private cloud, in a public cloud. So because of the pros and cons of these two deployment models, one thing that's more and more common is a combined deployment model where either you have multiple public clouds or you have a mix of public and private clouds. One of the well-known combination models is what's called a multi-cloud or a broker, by which you have a central point of access that allows you to instantiate computing resources in multiple cloud providers. This increases the portfolios of services available because essentially you are adding up the portfolios of multiple public cloud providers. And in some ways, it mitigates the problem of vendor lock-ins in the sense that now you can get service from multiple providers. Another way to combine clouds is to have your private cloud in your institution extended with the possibility of creating resources in a public cloud. This is called a hybrid cloud, and this feature is typically called cloud bursting your demand. So when your capacity reaches its maximum capacity, you don't have any more resources to attend the local demand, you can reach for the public cloud to attend that excess demand. Another utility of having this combined cloud scenario is that you can extend the service from your private cloud with those of the public cloud. So there are services that you do not offer privately, but you can access in the public cloud. Also, you can leverage on the fact that public clouds have data centers spread around the world to deploy applications that have some geosensitivity in their workloads. So try to serve your clients from a cloud provider that's closer to them. Finally, one also common way of combining deployments is the federation of private clouds. And here you want also to have this the geo distribution of the data centers, and here you have more flexibility in how you define the business model within the federation. For instance, one common way to do so is to barter, to use some sort of barter to exchange services without actually billing clients from the different providers, which is something that you don't have in a public cloud scenario. So all these very different ways of combining clouds have different pros and cons. And what Fogbow does is it provides a unified way to give support to all these different combination models. What I'm going to show here, just to finish my presentation and give the floor to Leandro, is some examples of how we have been using Fogbow to provide all these features mentioned before. So this is one first example where we are testing with RNP's public cloud and Amazon public cloud, the data center at São Paulo. We combine, we provide a server that allows users to have access to both the RNP public cloud and the AWS public cloud at São Paulo using the same API and the same, this dashboard is just showing so you can create compute instances, networks, and you can even create federated networks that allows you to connect compute nodes instantiated at RNP cloud with compute nodes instantiated at the AWS cloud in a completely transparent way. The next example is a cloud bursting example. So we have this our cloud at WebCG and an instance of the AWS cloud. So with this setting, we are able to provide a single interface to allow users to either create resources in our private cloud at WebCG or on the public cloud at AWS. And finally, this is something that we are trying out with RNP to federate all the private clouds belonging to RNP and its clients. So this is, it leverages on the IDP, Identity Providers Federation managed by RNP called CAFE. So users authenticate through this community of federated identity providers. And after that, they have access to the clouds that belong to the federation. Currently, we are running a proof of concept experiment where we have just two clouds, a cloud at WebCG and a cloud at RNP, as you can see in the picture there. So what I showed were three different ways of combining clouds using the same middleware, just changing the configuration of the middleware to address these three different use cases. So in just completing this use case, for each of these providers, they can manage different clouds. For instance, at our local site, we have two clouds, one that's our production cloud and another cloud that allows access to special kind of resources that have cryptographic features provided by the hardware. In particular, in this case, it's SGX features of Intel machines. More information about Fogbow can be found in our website. So there you can find information about the architecture of the middleware, how you can install it, and how you, more important, how you can contribute to this open source community. So we're saving questions to the end. So I'm going straight to Leandro, give the floor to Leandro. Leandro is going to talk a little bit about RNP's cloud strategy and how they are planning to use Fogbow in this in their strategy. So Leandro, please, the floor is yours.
Okay. So I was waiting to be promoted to presenter. So Rob, can you give me the superpowers so I can share my slides? Okay, thank you. Hold on. Okay, just to check, are you seeing this one slide?
Yep.
Yes? Okay, so actually, for Bika, I will do this narrative in a reverse order. I will start by explain a bit about Cloud Lab project, and soon you will understand actually in a minute how it relates to Fogbow. So Cloud Lab is a 2-year project that is ending now as a R&D project. That this project is let's say creating two different types of service. One is a test bed for experimentation in cloud computing. In another one is a service for, let's say, the long tail of researchers that they have a demand of running applications in the cloud. And usually it's focused to a user that, let's say, they are not so an expert. I mean, they don't know how to handle well Amazon, Azure, and other cloud providers. And at the same time, they don't have a big cluster in their lab. And eventually, they have a high demand of processing. They only have a couple of computers and perhaps only a notebook, and they need some extra processing power for a period of time, let's say to conclude uh, a paper before publishing it to a conference. So this is a kind of, let's say, a persona for who this service is dedicated. So this project is funded by FINEP, which is a funding agency from the Ministry of Science and Technology, so it's not a project funded by RNP. And well, talking, let me try to change my slide here. Okay, briefly starting by Cloud Next. So as I mentioned, is a test bed for cloud computing experimentation. Basically, it is formed by two rack of servers and switches in two different locations. One in Northeast Brazil, in Recife, another one in the University of São Paulo. And basically, it allows users to have access to the bare metal hardware. I mean, usually, if a user wants to run experiments related to cloud computing, I mean, want to compare, let's say, cloud computing technologies and orchestrators and or software manager of cloud computing, um, oftenly they need to have access to lower layer. I mean, in the physical layers and the physical test bed, relying only on computing machines, virtual machines that Amazon, Azure, or other public cloud provider provides. Often it's not enough for doing some experiments in comparisons. So the idea is to grant access to real hardware, and a user could, let's say, choose the flavor of cloud software he wants to enable in this service, like CloudStack, OpenStack, OpenNebula, whatever, and run comparison in any kind of experiments. And on the other hand, the other service is Iguaçu. That is a high throughput execution service, as I briefly explained before. So that's the point why I'm talking about this in this webinar, because Iguaçu also relies on Fogbow as a broker to let's say to send jobs to be processed in the multi-cloud. So basically here it's like a front end, a service. A user can configure a job and send it to Fogbow, who will act as a broker, and also can store the results in, let's say, in the driver in the cloud. In here, for instance, in the Do Drive, which is a Dropbox-like application, also provided by RNP. So this is another view to explain it in a simplest manner. At one side we have Iguaçu, which is currently configured to use WebCG, private cloud, RNP cloud, so we can mention, and also a user can configure it to use other public clouds. On the other hand, CloudNext, as I mentioned, it relies on two hack of servers of server in two different locations, and we imagine that we may not have too many researchers in Brazil that will keep using continuously this infrastructure provided by CloudNext. And we added here in the architecture that when those servers are idle, we will load a cloud, and it will be integrated to, let's say, the federation of clouds that will be used by Iguaçu. So this is the idea. If this testbed service, which is very specialized, if it is idle, it will be given to the Iguaçu Cloud Federation. And our vision here. So this picture may look like a bit confused, but I'm going to explain. So RNP is following a trend that some other NRENs are doing now, which is to have to act as a broker of cloud and applications in the cloud. So we have this project called Nas Nuvens, which in a free translation mean in the cloud, which essentially will be a web portal, like a marketplace. And in the lower layer, we will have some infrastructure providers, cloud providers, either these big cloud providers like Amazon, Azure, and Google, etc. Also, RNP, its own cloud, and also can be a federation of cloud provided or clouds from public universities in Brazil. So the idea is, let's say, if a CIO of an university wants to have some extra storage or processing capacity, or to have some service provided in the university in the cloud, he or she can go to the portal and select an offer from Amazon, Azure, or from other university that has idle resources, etc. So it will be in that sense like a marketplace, and RNP will be like or better saying, this Nas Nuvens portal will be this central entry point. In the upper layer, we will have some applications there. Applications target to, let's say, the CIO of universities, like Office, uh, email, let's say some applications that from the IT world, I mean Office applications, and also applications targets to the scientific side, like R or LaTeX or MATLAB, which one that we are working to integrate, and also access to some national platforms like those that are listed here, our national curriculum bases and other systems, libraries, etc. So here, just to illustrate a bit more, this is a screenshot as it will look like. So it's a portal. Let's say a user will log it in. The idea is we will have agreements with some universities, and in next August we will launch this service, starting with one university. It will be Federal of Uberlândia University, and the idea is that their graduation students and professors will have this kind of service available in the cloud, web conference systems, storage drive, Office, Microsoft Office, Google's, and the idea is in let's say in the second or the next version of this NAS Nuvens, let's say next year, also we increase the portfolio of applications for scientists, adding Iguazu entry point here in this marketplace, together with other tools that I mentioned, like MATLAB and LaTeX, for instance. So we'll stop my presentation now. This is just an overview of our plans into offering cloud service for the Brazilian academic community, and how we measure to integrate Iguazu on that. So, thank you.
Thanks, Leandro. Thanks for very nice presentation on RNP's cloud strategy. That's nice. I see many opportunities for collaborations there. I'm going to. We're going to move now to the Q&A part of the webinar. We are going to handle this as follows. If you want to make a question, please raise your hand using the appropriate tool in the dashboard, and I will unmute your microphone so that you can make a question. Before people get started there with their questions, I'm going to make the first question to break the ice. So Leandro, as I understood, so the plan for NAS Nuvens is to engage RNP, the community around RNP, the clients of RNP, the partners of these clients, to enlarge the portfolio of services provided through to the education and research community through the NAS Nuvens portal. How do you see any benefits that this community could get from, for instance, using Fogbow to help them in in providing their service in this environment? Do you see any ways that Fogbow could leverage people and facilitate the adoption of service in this environment?
Okay, thank you for this question. I'm trying to share my screen again just to show, to come back to that that image. So in the lower level here, so we sorry, I forgot of translating this. But we have here also an option of have also a federation of clouds, of opportunistic clouds, as one of the possibilities of a user using these resources. I mean, a CIO can, I believe, a CIO of a university in the future can choose, okay, I want this offer from Amazon, this offer from Azure at that cost. Oh no, I want this one in the opportunistic view using from the federation at a much lower cost of, let's say, not free of charge. So we still need to build these agreements. Let's say could be a model like, okay, if your university is part of this federation, you can get outside the idle resources from the other members of the federation for free. This could be a model. But okay, I see Fogbow in two ways. One, perhaps enabling this kind of shared of this kind of opportunistic cloud infrastructure to be provided in this environment, or also tied to Iguaçu. If you only look at Iguaçu, we can try to increase the service by having others to commit manpower to it, manpower, no, processing power to it.
Yeah, I agree that you know, FCG is also involved at Iguaçu, so I'm aware of what's being developed there. And one of the ways that I think would be interesting to leverage Fogbow is that the cloud infrastructure at RNP, or that is provided by this portal at RNP, is quite complex, because you have different providers and different ways of associating these cloud providers. And Fogbow provides an easy way for applications to use these services without needing to care about how their service needs to interact with each of these different clouds. So it provides a single API that allows very easy combinations of, so it will, the use of Fogbow in this very complex cloud infrastructure will allow the partners of RNP trying to propose new services to care about, to concentrate their efforts on their business and leave this interaction with the cloud to the Fogbow middleware, which might make the time to market of these new services a lot faster. And because also they can customize Fogbow with their own implementation of the plugins, if they don't like the way the software, the default implementations are placed there, they can always develop their own solutions for integrating with particular clouds. Do I see any hands raised from the audience? No, I don't. Don't be shy.
I don't know you, but I can't see the whole list of participants. I see
Well, there is
12
a
people,
tab
but
up. If you click on attendees, you probably are seeing this stuff tab. There is an
Yeah.
attendees tab,
Okay.
8 people there. So I see Thiago Silva, just gone. I see Marco Latuda, Giannis Ledakis, Eduardo Ramos, Danilo. Ciao,
Okay,
Danilo.
I found it.
Carolina Felicissimo. So if any questions from the audience? Well, if not, perhaps we can close the webinar now. Thanking everybody for attending. There are pointers in the presentation that can be followed for more details. There are also my contact and Leandro's contact. You can always contact us by email for further information. And the slides will be available at the website of the Atmosphere project, so we can always see them there. So thanks Leandro for accepting the invitation, and thanks everybody for attending. And I give the floor to Leandro for his final remarks before we close.
Just to thank the opportunity, and just to mention that I pasted in the chat the URL for Nas Nuvens. You can find more information about the service there, and just to say again that in next August, during our annual event, Forum RNP, it will be launched in a broader way. So currently that's only like a landing page there.
Okay then, thanks everybody, and see you in another opportunity.
Bye bye.
Bye.